on U substitutions, but we'll grade it in class. No, they're not so easy. There was a green sheet from a few days ago with slope fields on it. You were told to do that. And we could do that one first. It's right here. You should have these. You have these. I only have so many. Just a little bitty quiz. The test is Thursday, Friday. Should have this. All of these are practice tests. These are, yeah, see, you've got it. So we didn't do this one in the other class, but we can. You may not have any. I don't know. You have the other ones? Okay. So the one thing I want to talk about, and then you guys figure out what you want to ask me, because today's the day to do it. So is Thursday morning, but, you know, if everybody comes in on Thursday morning, well, you know how that goes. Right now, I haven't been terribly busy. What is the antiderivative of this one? That's the natural log of the absolute value of x. Yes, we do have meetings tomorrow morning. Can't. Okay. Now, here's the problem. I see this, and a lot of you want to say that's the natural log of x squared. How do you know it's not right? Take the derivative. So we're going to take the derivative of this. Well, log of x squared is 2 times the log of x, really. And then we'll take the derivative of that with respect to x. So that would give me 2 times 1 over x, which clearly does not equal 1 over x squared. So it can't be right. For you to use log, it must be 1 over x to the first power, or it must be x to the negative 1 dx. Only through a u substitution can you see it when the function's complicated. This is just a simple old power rule. Noah? It's x to the negative 2 dx, and if you integrate it, it's x to the negative 1, a little more, divided by what? Negative 1. Well, I think that might be the first question. It is. It's the first question on the pink packet. So a lot of you, they put the distractor first. A lot of you would write A down. Do this packet? No, yesterday. I always keep all the sheets over here. AB is on the lower shelf, yes. I do believe it's online. Anybody else that missed yesterday that needs the materials? And then what we did in the other classes, then we did number 2 because I had questions about that. Now, we could also do a little test taking when we talk about question 2. So what's the answer to number 1, by the way, in the pink one? Yeah, it's D. But you see how they put the distractor first, so you just say, oh, it's the log of x squared. And then you're going to get it wrong. It doesn't mean you don't know it. It just means that you got caught. That's all. So if we look at the second one, number 2, these are all AP questions. It's the sine of 2x plus the cosine of 2x dx. Okay? Jack, we're working on these. You should get these out. This is the time to do it. If you look at your answers, you know you can rule out some of them. What is the antiderivative of the sine function? It's not a power. It's a cosine, right? So when you look down here, well, maybe I can't rule them out. Not quite yet. But if they had had cosine squared, I would have been able to rule that out. So let's do a u substitution. Let's let u equal 2x. Then you must write down your du. What's du? 2 times what? Times dx. You must have that because what I'm going to do is replace this dx here with, I solve for dx, it's 1/2 of du. So it looks like I'm going to have a half there. So guess what I can do? Rule out c, d, and e. Because it's 1/2, isn't it? So it's the integral. So this is going to be the sine of u, and I have a 1/2 d, and then a du for this one. Plus, I'm going to break it into 2 integrals because I can. And it's the cosine of u, whoops, the cosine of u du, and what has to go out in front of this one too because of this 2x? 1/2, not 2. When you solve for dx, it's the opposite, it's 1/2. So now I know it's between a and b, and I know it can't be a, because what has to be true? The antiderivative of sine and cosine, one of them has to be negative, doesn't it? So without even doing any work, I know the answer has to be b. So let's go ahead and do it. This is 1/2. Let's say the derivative of the cosine. No, cosine of u. Did I say it wrong? I said it wrong. Yeah, sorry. And what's the antiderivative of the cosine? That's the sine. Plus c. Maybe put the c's in there. Good. So this is negative 1/2 cosine of u, but u was 2x, plus 1/2 the sine of u, but u is 2x, plus c. So the answer is B. Okay? You see, I could rule out the other ones, provided I know how to do my u substitutions. If you see a times 2 here, it's going to be divided by 2. If that were divided by 2, then it would be times 2. So those are the real quick ones that we did. What else did we do? Also did the third question. You want to do the third question? Just turn your page when you're ready. And for sure, we better look at number 4 before Thursday. So try it. I don't think I'll do it today. I don't think I have time. Yeah. Well, we're losing a little bit of time, but at least we didn't lose the day. Okay. I got to get this to look like the power rule or a sine or cosine. Certainly doesn't look like any trig that I can remember. So why don't you let u be what? And you could let it just be x squared if you prefer, but I like to have as much as I can. So x squared minus 4, just to keep it simple. And so then du is what? 2x dx, that's right. And then I don't want 2x dx, I want x dx. So what's going to go out in front? A 2 or a 1/2? Divide this by what? 2. So 1/2 of du. Does that make sense? Because that's what this is. This equals 1/2 of du. We're going to substitute. We're going to replace it with something else it's equal to. And then this is just plain old u. Now it looks familiar. Now it looks like the integral. Let's say I've got a 1/2 out in front, and then I've got a du over u. And if you don't like that, I'll rewrite it as 1/2 times the integral of 1 over u du. Anybody recognize that one? That's the log. If the exponent is 1, which it is, then it's the natural log. So it's 1/2 the natural log of the absolute value of u. But what was u? X squared minus 4 plus c. You probably have to do it. Let's see which one it is. So once you know it's a log, then we've got it ruled down to c and d. And then you remember, if there's a 2 on this side, it's going to be 1/2 when I put it over here. Those are just quick little checks to say, yep, I did it right. And just to keep my classes the same, we should do probably the third question in the yellow packet, which is a nice little question too. Unless you have something you'd rather do. Doesn't matter to me. Number 5. Well, 5 is very similar to number 6 on the yellow packet. I don't know if it's any easier. Are you ready for me to switch pages? Yeah. Okay, this is 5 on the pink packet. And it says dy dx equals, is that x squared over y? This is just a differential equation, and I know that y of 3 equals negative 2. So that's the order pair 3, negative 2. Now, do I need to write down the steps again to remember what the first step is? Because this you can memorize. This you can get. Separate the variables. So this is a little easier. separate the variables. How are we going to do that? Just cross multiply. Multiply these guys together and these guys. Hopefully everything's going to land in the right place, and it does. It's y dy equals x squared dx. Now, if this were free response, we'd have to worry about all these. This is going to be just finding the answer, which is not necessarily easy. Oh, and I know exactly why. Okay, then what are we going to do? Since the variables are separated, free response, you got a point. Variables are separated, what do we do next? Integrate. So we're going to integrate that, and I'm going to get what? What's the antiderivative of y? Y squared over 2 equals x to the what? Third over 3. And while it would be easier to ignore the c for right now, it would be wrong. So it's plus what? C, because that changes the whole thing. So if you're in the middle of a free response question, you go, oh my goodness, I'm at the end of it and I forgot to add C, cross all that out, go back to where you're supposed to put C in, and work again from there. Because the minute you put the C in too late, we just ignore it. It's got to go in when it goes in. So we're going to add C. That's worth 3 points. Well, not on multiple choice. And then we're going to put in what? Substitute what? The initial conditions. That point. Because I want to know the function, the picture of the function that goes through that point. Okay, so in place of y, and you get a point for this. In place of y, you're going to put in what? Careful. -2. Yes. Is it easy to put them in the wrong place? Probably. Because you're stressed. It's not like here. You're not very stressed. I mean, you are stressed. I'm not saying that you aren't. But when you get in that testing situation, it's a different kind of stress. So what am I putting in for x? Oh, darn it, I can't see what it was. It was 3. So 3 cubed over 3. Now, because this is multiple choice, you have no choice but to simplify that. If this were free response, you could just leave C as this number minus that one and be done. But can you do this in your head? What's -2 squared divided by 2? 2. And 3 cubed divided by 3? 9. So what's C equal to? C equals -7. That's right. So I have y squared over 2 equals x cubed over 3 plus or minus 7. So what we need to do is solve. What's this thing about the 7 at all? Well, first thing is, I don't like fractions. Do you like fractions? So let's get rid of them. What can we multiply by to get rid of them? 6. And the more you do, the better you're going to feel about this. Because you'll start getting them right. You just do lots and lots of problems. I know this will be free response. Well, I'm pretty sure it'll be free response. 3y squared equals 2x cubed minus 42. Now we know what to do. What do we do next? This is a long problem for multiple choice. Divide by 3. So other ones will take less time, so it does balance. Well, then I get these fractions, and I'm not so good with fractions. Actually, I'm really good with fractions. It doesn't matter. But I know you guys aren't always so good. What's 3 into 42? 14. Now, this is the hard part. How do you solve for what? You square root both sides. What is the square root of y squared? It's the absolute value of y. It's not plus or minus. What is this one? This is the positive square root of this. Do you see any forms that look like this on your answer sheet? Yes? It looks like D and E. Read through all the answers before you make your decision. So it's from the absolute value that we get the plus or minus. So we get this as a solution. And I know this seems really tiny, but we have to be careful with this. Y equals minus the square root of 2/3 x squared minus 14. And I must be deciding between those two. And I do that by looking at my point that it went through, which was 3 - 2. 3 negative 2 will only make one of these equations true. Remember, we're solving. This point will make one of those equations true. Which one is it? Can't make them both because it's not a function then. If it makes both true, then it's not a function. If you put in x is 3 here, you get y equals negative 2 equals the square root of 2 thirds times 9 minus 14. Square roots are always positive. Is that true? Square roots are always positive. So that's not true. Let's try this one. Negative 2 equals negative square root of 2 thirds of 9 minus 14. So what's that going to give you? Well, what did I do wrong? Oh, that's probably why. How did I? Oh, I copied it wrong. And by the way, I'd be in trouble. Now, in the old days, they didn't charge you for the copy error. They do now. So this is not 9, but what? 27. How did I know I did something wrong? Because I was going to take 6 minus 14, and I can't square root a negative. Oops. 2 thirds. Yeah, but you'll never get imaginary numbers on this exam. So if you do, you know you did something wrong. Only the reals. So 3 goes into 27 9 times, right? 18. 18 minus 14 is what? Is that a true statement? It's the initial condition that gives you the plus or the minus answer. It'll be one or the other, but not both. That was not an easy question. If you know what exam year it comes from, you can go look it up and see how many people got it wrong. It's kind of interesting. Because for one thing, I'd like to have you do that when we give you the multiple choice questions, because you go back and you say, oh, I got this one right? And you go and say, well, 60% of the people got it wrong, but you got it right. So you can be really proud of what you've done, because you've really learned a lot. You know a lot. But this is one set up to trip you up. We put the negative answer last. You just go for the positive one because that's what you're thinking. That's what they want. So be careful. Read all the answers. Now, do you want to do the yellow one? Number 6. Oh, this is a slope field. Okay, that'll be a little tough for me to graph, but I'll do my best. This is 27. The question is, how do you do a slope field? Okay. Sometimes you can just solve. What does that look like? Oh, it looks like x squared, doesn't it? Okay, so what you're going to look at is, what are the ordered pairs here? No matter what the y value is, the x value is negative 1, and the y value is any number. What's the slope there? Is 0. So when I look at my differential equation, I'm not going to have any y's in here, because the y is not going to change the slope, is it? So a says dy dx is equal to x times y. Well, as y changes, when x is negative 1, as y changes, this value is certainly not going to be 0. Not that one. Matter of fact, you can do it fairly easily if you think about it. You can't have a y here. So if you look through all of them, there's only one that does not have a y. dy dx is equal to x plus 1 cubed. I guess it would be cubic when I look at it. So, because we could do this and then 0 out and then do that. But look at your slope field here. When x is equal to a negative 1, what's the slope equal to? Negative 1 plus 1 is 0. So that would give you this. If these are changing, then you're going to have a y there. If they're all the same across this way, horizontally, then the dy dx will be y, some function of y. So let's write that down. Dy dx equals some function of y, no x's, if it's the same horizontally on your slope field. That's a nice little trick. So that would save you a bunch of time. Remember all the time we spent on the last one? This one was easy. Well, let me write this down. Dy dx, if that's equal to some function of x and no y's, it's the same. Okay. It's the same vertically. If you have them both, then the slope field is going to be changing every single point in the graph. And you could try values, but I certainly would try x equals a negative 1, which makes the slope 0 here, no matter what y is. If you try it in all these choices here, you'll see there's only one that works, and that would be E. Okay, now do we want to do the yellow one? Or do you want to do more out of the packet? What? Yeah, yellow one, number 3, the third page. It's a nice little problem. You could have a bird problem, or you could have one that looks like this. That I don't know. They do lately they've been they like to be able to give the problems names. So my guess is it's going to be some sort of name. This is just a straight old differential equation. This is 2010, number 6. And the important part's right here. Without reading anything, dy dx is equal to xy cubed. And I'm thinking, ooh, that looks like a differential equation, because I know what a differential equation is. And I also have the second derivative. They don't want you to find the second derivative, because if you look at this, you're going to say, that's really hard. It is. So they give it to you. Now, the fact that they give it to you means that you're probably going to use it for something. Otherwise, why give it to you? They don't usually like to give you a lot of extraneous information. Okay, A says, write the equation of the tangent line to the curve. I don't know what it looks like. It could look like this. I want to write that equation of that tangent line at 1, 2, or it could look like this. I mean, there's a lot of things it could look like. Depending on what it looks like will depend on some of my answers. So the minute they say write the equation of the tangent line, I'm going to write the equation of any old line. You do not want to use y equals mx plus b, because then part B isn't so easy. It's okay, but this is much easier. What are constants in this line here? Is the y value? This is a value, right? That's the point it goes through. Same with x. What else is a number? L. So if you put in this, some people wanted to put this in for m. You can't put that in for m. It has to be a number. A slope is a measurement of how steep the tangent line is. That's all it is, and it's a number. Letters never represent that. Okay, so let's put in what we know right away. So it's y minus the y value. What's the y value? 2. Read through the whole problem so you can see if you can find it. I put this down and say, oh, I got to find that problem, that point. I don't know where it is, but then you read and say, oh, there it is. And then it's x minus 1. How do you find the slope? That's this, right? Substitute in 1 and 2. So x is going to be 1. Y is going to be 2. So it's going to be 1 times 2 cubed, or 8. You could leave it 2 cubed. Who cares? That was it. There's no calculus there. That's it. Too easy, isn't it? I don't know if it's 1 or 2, but my guess is it's 1. It could be 2. I know that part C is only 5, so I've got to get 4 points out of the first 2 questions. So it could be 1 and the next one's 3, or it could be 2 and 2. Okay, B. Now, it says, use the tangent line equation from part A to approximate the function, the actual value of 1.1. So, if this is 1, and then this is my 0.1, this is 1.1, I want to use this point here to approximate that y coordinate. Or, maybe it's this point over here. I want this point here to approximate that y coordinate. You see what they're asking you to do? They just want to find out what that y coordinate is. It's pretty close to that, but it's not exactly that. That's how your slope fields work. That's how your calculators work. They all work that way. Okay, so I know I want to put in 1.1 into this equation. So y minus 2, and don't change to y equals mx plus b. It's much harder. And then you're going to solve for y. So y equals 2 plus 8 times 1.1 minus 1. This is a non-calculator question. I don't need to simplify that. It's good enough. We're going to do it because we can. It's not that hard. But I hate to see you get it wrong when you do this wrong. 2 plus 8 times 0.1. See why I want to leave it in that form? I'm pretty close to the point where I made the approximation, so it's a pretty good answer. So y is equal to 2.8 on the tangent line. And then they ask, is that an overestimate or underestimate? And so how would you know? What do you have to test? I got two situations here. What's the difference between these two guys? Concavity. How do you find concavity? Second derivative. So why do you think they gave you the second derivative? Right here. Because they wanted you to test for concavity. If you put in 2 here, and you put in 1 here, and 2 here, what's true about my second derivative without doing any calculation? It's positive. Yeah. So that's greater than 0. So the function at that point is concave up. And I would draw the picture just to make sure that we are convinced that you know what you're doing. Yes, it's an underestimate. I have not memorized that. I just draw the pictures and it just pops out. Yes. Nope. This has to be concavity. Doesn't matter. Because if I draw one like this, that's a decreasing but concave up. The tangent line still lies underneath it. It's the Riemann sums. Well, then I feel like over and under has to do with the increasing, decreasing piece. And we'll review that before the exam. Okay. Now, the part where you get the most points is solving the differential equation. And this one actually isn't that bad unless you make the regular boo-boo you make. Okay. So dy dx is equal to xy cubed. And you do have answers to this because I have taken the smartboard. I'm not using it today, but I have put it up on the Schoology. Did I export to a PDF file? You have the answers, even if I don't have the work for you guys. Okay, so what's the first thing we do? Cross, multiply. You have to have a product here. Okay, everything's fine except for we have to separate. There's one variable that's causing me problems. Y cubed. Y cubed is on the wrong side of the street. So we'll divide. Yeah. Think of, I don't want to go there. We'll divide by y cubed. And this is where we have some problems integrating. So you get 1 point for this. So it's 1 over y cubed dy. Now this depends on the question leader as to whether or not they'll accept the log of y cubed. They won't. That's not right. But will they follow along with you in the rest of the problem? If there are a lot of people saying that's the log of y cubed, yes, they probably will. So I can't guarantee how this was graded. So if you mess up your integral, you might be done. It's not the log of y cubed. This is the power rule. All you get is the log of y. How about if you remember that? So log of x, log of z, no log of any powers. So it's y to the negative third dy equals the integral of x dx. And how do you integrate that, Jack? We got 2 minutes. This is y to the what? Negative 2 over negative 2. So equals x what? Squared over AJ over 2, right? Plus c. You got a point for separating, a point for integrating both sides correctly, a point for adding c, one more point putting the initial conditions. It doesn't matter. You can put c's on both sides, but we're going to put all our numbers on one side. They're just numbers. I'll figure out what they added up to. I don't really care. Okay, so what's the point? 1, 2? Now you got to put them in the right place to get this point. What goes in for y? Now I think there's going to be some of you that will evaluate that wrong. So you lose your answer point. 1 squared over 2 plus c. If you don't want to evaluate it, you don't have to. You can just leave it that way. But what's 2 to the negative 2? Yeah, you don't have to do that. That's what? 1/4. Okay, we will finish this tomorrow. You guys finish it up, see if you can solve for y correctly. This one's kind of nasty, I recall. This one's very nasty. And have fun in the snow.